Good afternoon, everybody. I'm the Lieutenant Colonel Alexandre Papy, and I'm working in the Department of Weapon Systems and Ballistics of the Royal Military Academy. And today I would like to talk briefly about the way to counter low, small, and slow UAVs. What are we talking about? On the screen you see what is allegedly the biggest drone on the market. That's obviously not really what I would call a low, small and slow UAV. We are more thinking about these small rotary wing or fixed wing drones that you can find easily on the market. We can find some classification. So on the left side of the slide, you see some US classification. On the right side, some NATO classification. And of course, they are not really covering exactly the same types of drone. Anyway, when we talk about low, small, and slow UAVs, if I look at the NATO classification, we are looking at class 1 drones, mainly in the micro or mini category. This is a slide about the capabilities of these drones. An example from the family of DJI drones easily procurable on the market. They are small, but they can fly during a relatively long time. They can be very fast. They can operate at a relatively long distance, and they can carry some payload. Last but not least, they can also fly autonomously. So indeed, that can be a threat. And I propose now to have a closer look at that threat. A drone can be divided in different subsystems. I will not take time to go into the details of these subsystems, but what I would like to underline here is that on top of the remote, the main components of the drone, we can also have a payload. And the payload can be, well, some sensors, some camera, but can also be composed of explosive or CBRN material. And that's why the threat can be quite important, and it is important to be able to handle it. Does it mean that we have to destroy all the drones from the sky? Well, not really. There are some people having fun with these drones. These drones can be also quite useful to deliver box, to deliver medical material, for example. And indeed, cash is king. These drones are bringing a lot of money in the pocket of people and the companies. So it means that we will have to take care of the threat while having also acceptable flights of drones in the sky. If we have a closer look at the threat, we can see that most of the people, most of the users are compliant. They will follow the rules and they will fly safely in authorized zone. On the other hand, we will have some people being careless, being mostly safe, taking some freedom with the rules. There will be also some people not knowing what they are doing, the clueless one. And on the extreme side of the spectrum, we have the crazy people trying to find some thrill by flying dangerously drones, and also criminal or terrorist use of these drones. I would like very quickly to give some examples of these misbehaviors of the users. That is an example of a clueless person, a mid-air collision with an airliner in Argentina. You have also an example of a crazy behavior with people flying very close to planes during the approach, and that happened here, for example, in the United States. But what we are really looking at are the people using drones as a threat, as a weapon. So that is an example of a person who used some radioactive sand from Fukushima and put a little container with that sand inside and tried to land a small drone in front of the Prime Minister office. We have plenty of examples in Syria of drones being equipped with some explosive devices, such as a grenade here. You could wonder, is it easy to do that? Do we need special training or skills? Well, by just looking on Amazon, for example, you can see that delivery mechanism can be bought for a fraction of the cost of the drone. And of course, these devices are sold to deliver some flowers or some engagement ring, but indeed you can use them for something very different. So my point of view is that the threat is active. It's not if we will have a threat coming from small UAVs, but more when it will happen. So now we understand that there is a threat. We should have a look at the way to give a response to that threat. And there is indeed some context. We have some kind of escalation of force in the measures we can take to neutralize at the end if needed this threat. And that goes with some information to the pilots, some deterrence measures like identifying the UAV owners, like implementing geofencing, like having some unmanned traffic management in place. But indeed, in the framework of this little talk, we are looking at what we can do during the imminent threat, meaning how can we detect the drone, how can we make a decision, and how can we neutralize them at the end. I stole this slide from another community of interest, which is the counter-IED community. And fighting small drones is a bit similar to fighting IEDs. So you need to perform different actions. The first one is to defeat the device, but you should also try to attack the network, the people who are training the pilots, who are preparing the drones, and you also need to prepare the force with a proper training. So let's have a look now at what we can do during this imminent threat. And let's add as well that in most of the case, as we want to attack the network, we would like also to recover the drone in order to perform some forensics or exploitation tasks. We can wonder, well, we are military, we know what the ground-based air defense is, so it is quite similar to fighting aircraft. Well, in certain way, yes, in other ways, no. There are some differences in the way we can handle unmanned aerial systems, and it means that we need to have dedicated means in order to do that. And these dedicated means are linked to what we call a kill chain. The kill chain is composed of different parts: detect, track, identify, and neutralize. Let's have a look now at these different parts. The first thing when you have drones in the sky and you want to neutralize them is to be able to detect them. And it's not as easy as it sounds, because on this screen there is one drone. Can you identify it? Can you detect it immediately? Well, it's here, and that is what we are asking our set of sensors to detect the drone very quickly. After that, we would like to track it, meaning we'll use the different position of the drone related to time to be able to predict a future position. We also want to identify that drone. Is that drone a drone or a bird? Are we talking about an enemy drone or some authorized drone? Well, that is something that we also should do before going to the neutralization part. How can we do that? Let's have a look at first at the detect, track, and identify part of the kill chain. We have different kind of sensors that can be used in order to detect, track, and identify the small drones. I will not go into the details of this sensor. I will very quickly cover them. But the first one, the number one of this slide, is the radar. That is an active mean that can be used in order to perform the required task. We can use in place of or on top of this sensor some passive sensors like a camera, electro-optical or a thermal camera. We can also use some passive radio frequency sensors, that is the number 3, and we can also have another passive acoustic sensor. Last but not least, we can also put different sensors on a surveillance drone that becomes also some active mean. And the sum of the data that we get from these different sensors should be sent to a command and control, a C2 system that allows the user to know what is happening, but that also gives information to the neutralization effectors. How does it look like? Well, that is an example of a C2 system. You can see that there is a target or a critical infrastructure that we are trying to protect. We see one of the different sensors that we are using in order to do that and the detection zone. And you can see on the right side of the slide that one drone has been detected. What is best to use? Well, very difficult question. In fact, the different sensors have strengths and weaknesses, and one sensor only cannot really cover accurately the whole domain. So at the end of the day, what we are usually doing is using some radar, and we are adding some other sensors to the radar by doing some sensor fusion. And usually we are using certainly ground radar, electro-optical systems, and most of the time radio frequency sensors. Just one word about the sensor fusion. It's very easy to say that we have to combine the results of the sensor. It's much more complicated to do that accurately, even if most of the companies are offering some systems such as the one on the left side of the screen, where you have the combination of different sensors. After the first part of the kill chain, we need to go to the neutralized part of the kill chain. And I will use that diagram that is covering all the different aspects of the possible interaction with the drone. At first, I will look at the top right and see how the drone is flying. You can have some manual flight, like using a remote control. Then you can use some kind of automatic or supervised flight using the remote control or not. And on top of that, GNSS systems such as the GPS. And on top of the slide, you have what we call the autistic flight. And in that case, the drone can fly completely autonomously. You have an example on the picture on the right of a GPS denied capable drone, meaning that that drone can fly without remote control and without the use of the GNSS. It's using some kind of a stereoscopic camera. And just to give you the importance of that system, that is mostly what a Tomahawk cruise missile is using, but really for a fraction of the cost. After that, we can have a look at the different arrows here on the slide that shows how we can interact with the drone. So we can interact with the control station, meaning the GNSS signals. We can interact with the ground control station, remote control. We can interact with the structure of the drone. We can restrict its mobility, and we can also have an influence on its payload. Well, how to do that practically? These are the different numbers that you see on the slide. Number one, we can try to jam the communication between the drone and the remote control. We can try to hack, so to take control of that communication. We can also try to jam or spoof the GPS data. Number three is to use a laser. We can use a low energy laser to blind the payload, the camera in that case, or we can also use a high energy laser in order to destroy physically the drone. Number four is using hyper microwave to destroy electronically the drone, while number five is a physical destruction using a projectile. Last but not least, number six is the physical capture of the drone using, for example, a net. We need to know what the effects of these different technologies are, what the limitations are, and also what the collateral damage of these systems are. One more remark about that is that most of these capabilities, most of these technologies can be put on a drone in order to be closer to the target. I will go relatively quickly on each one of these technologies. The RF jammer is a relatively not expensive technology that will non-kinetically neutralize the drone. The negative points are that these systems are usually usable at a relatively short range and that you can have a lot of effects on your own communication and systems. Also, the drones, you're not really controlling what the target drone is doing, and you have different types of behavior that can occur. You can also you can also jam or spoof the GPS, but that is once again something that usually we don't like to do because we are also using the GPS in order to support our own operations or activities. The second possibility is to hack the drone. In that case, you have, of course, the full control on the target drone. The limitations of this technology is that it's not possible to do that on each drone, on every drone, and basically most of the systems, they have a database of drones on which the hacking is possible, and you don't really know in advance if it will work or not. The third possibility is to use a laser or a low energy laser like on the right side of the slide in order to blind, to dazzle the camera, or an high energy laser. Of course, you will physically destroy the drones, and because of the speed of light, it will be really easier to bring that energy on the drone. On the other side, the drawbacks are the high cost and the risk of collateral damage when you are using the laser. Hypermicrowave, that is a system that is sending energy in the waves, and the goal is that these waves, this energy will interact with the electronical parts of the drone. So that is quite effective. That is not kinetic. That is also a system that can natively work with multiple drones, but on the drawbacks, you have a high cost and also the risk to interact with the own electronic materials that are in the surrounding. Another possibility is to use kinetic systems. So kinetic systems can be divided in specific systems developed for drones or just the use of legacy systems, being individual weapons or remote weapon station. The biggest advantage of that is the versatility of this solution, because most of the time, if you are talking about soldiers, the soldiers are already equipped with the weapons that can be used for another mission. Obviously, you need to reach the target, and the success rate is not really high today with the legacy systems. An airburst system, that is some very specific kinetic system, and the idea is to bring a projectile in the surrounding of the target and to make that projectile explode, bringing fragments in the surrounding of the drone. It works very well. You have different systems having advantages and disadvantages, but that solution is really something to consider, and that's maybe a bit counterintuitive at the first glance, but the collateral damage of these systems can be even lower than a classic projectile. Then we have the nets. Net systems exist from dedicated launchers or drones, are usually propelled at a relatively short distance. That is the main drawback. On the other hand, the positive points are that the drone is captured, usually not damaged, leaving it available for the forensics or exploitation, and also the collateral damage is quite limited. As I mentioned during the introduction to that part of the talk, you can also equip different drones with different technologies such as HPM, such as nets, in order to bring the effector closer to the target. Well, after seeing the different possibilities, the question is, what is best? What do I need to do? And as usual, the answer is it depends. It depends on several aspects. Who are you? Are you a soldier? Are you a soldier from a classic unit or special unit? Are you from the law enforcement? The second question is about the target. What is your target? Is your target specific? A dark drone, a drone with countermeasure, or a buy on off the shelf drone? Are you talking about one drone or multiple drones or swarms? What is your position about collateral damage? What is the importance of forensics or exploitation? Are you operating in an expeditionary mission or in your homeland? All these questions have an influence, and at the end of the day, that is the scenario that will really define what the best solution is. About the detect, track, and identify, well, you can clearly see the pros and the cons. And as I mentioned, the use of a radar and electro-optical systems is usually paramount. When we are looking at the neutralization part of the kill chain, well, we have different types of technologies having some type of soft kill or hard kill effect, while having different type of maturity levels. I have to say that today the conventional weapons, conventional kinetic weapons, the nets and the jamming are the most developed technologies, but we have the kamikaze hit-to-kill drones, the net drones, the hacking and the spoofing, and the lasers that are going more and more to the right side of this diagram. We are reaching now the end of that little talk. I was very happy to share this thought with you, and there is now, if I'm correct, sometimes for the questions.